This is section 7.1. We're going to be talking about graphing and functions. A lot of this first part is just review. You should have seen this in Algebra 2. You should have seen it in Geometry, Algebra 1, Pre-Algebra. But just to make sure everybody's talking the same language. The horizontal number line is called the x-axis. That's this one right here. Vertical is the y-axis. Where these two intersect, right here, that is called the origin, or 0, 0. Negative numbers, those are to the left and down. Positive numbers obviously are to the right and up. We have these axes divide the plane into 4 quadrants, what we call quadrants, starting with this one, working our way counterclockwise. This is the first one, second one, third one, and the fourth quadrant. This is one of those rare circumstances where we do actually use Roman numerals. If we have ordered pairs, an ordered pair, the word ordered is important. What that means is the order of the numbers makes a difference. So if we write -5, 3, that's not the same thing as 3, -5. This first number deals with the x, which is left and right. The second number deals with the y, which is up and down. So ordered pair does make a difference how we write those numbers. Probably not going to plot all of these, but let's plot at least a few. So let's suppose I have the point -3, 5. So my x value is -3. That means go to the left 3. And then my y value is 5, so go up 5. So I'm going to go to the left 3, and then I'm going to go up 5. So 1, 2, 3, 1, 2, 3, 4, 5 gets me a point right here. Okay, and this we would label point A. Point B is the point 2, -4. So I'm going to go to the right 2 and down 4. That's the point. That's the point B. Let's do C is the point 5, 0. That means go to the right 5 and go up 0. So that's this point right here. And maybe one last one. E is 0, 4, so go over 0, up 4, and that is the point E. So you get the idea. You should remember this from other classes. A relationship between two quantities can be expressed as an equation in two variables. This is an example, y equals 4 minus x squared. A solution of an equation in two variables is an ordered pair with the following property. When the x-coordinate is substituted for x and the y-coordinate is substituted for y, we can obtain a true statement. In other words, if you plug the numbers in, you're going to get something that's equal to each other. The graph of an equation is the set of all points that are solutions to the equation. In other words, the graph is a picture of all the solutions to an equation. There's different ways of graphing. We're going to talk about point plotting in this particular example. So what that means is take several x values, find the y values, plot the points, and connect them. Now, a lot of students are confused by this notation right here, so pay attention. What this means is starting with -3 and ending with +3, you are going to plug in every x value starting with -3 ending with positive 3. So when you do a table of values, let's get some room here. When you do a table of values, you are going to start your x value with negative 3, and you have to go all the way up to positive 3 with all the numbers in between. So negative 2, negative 1, 0, 1, 2, and 3. Yes, you do have to plug in all of those numbers to get your y values so that you end up with 7 points. Our equation, y equals 4 minus x squared. Y equals 4 minus x squared, and I'm going to plug negative 3 in for x squared. So y is equal to 4 minus, remember when you plug in numbers, you have to plug in numbers in parentheses. So this is equal to 4 minus a negative 3 times a negative 3 is a positive 9. So I have 4 minus 9, which will give me negative 5. You're going to do that with all of your x values. So the next one, y is equal to 4 minus a negative 2 squared. 4 minus negative 2 times negative 2 is positive 4. 4 minus 4 is 0. Plug in negative 1. Negative 1 times negative 1 is positive 1. 4 minus 1 is 3. Plug in 0. Four minus 0 is 4. Plug in positive 1. 4 minus 1 is 3. Plug in positive 2. 4 minus 4 is 0. Plug in positive 3. And 4 minus 9 is negative 5. All right, you are going to take each of those points and you're going to plot them. So negative 3, negative 5 is here. Negative 2, 0. Negative 1, 3. 0, 4. 1, 3. 2, 0. And 3, negative 5. Okay, so you plot those points and then you're going to connect them. Try again there. And that would be your graph. If an equation yields precisely one value of y for each value of x, we say that it is a function, and function notation is f with the parentheses and the x. Now, this is a case where parentheses does not mean multiplication. It means you have function notation. This is read f of x, not f times x, and it means y. So if you see f of x, what it means is we're replacing it. We replaced y. So y is the same as f of x. F of x is the same as y. The wage gap is used to compare the status of women's earnings relative to men's. And by the way, women earn less than men, still even today, for the exact same job with the exact same experience. No, it's not fair. The wage gap is expressed as a percent and is calculated by dividing the median, which is the middle number, annual earnings for women by the median annual earnings for men. The line graph, which is here, shows the wage gap for selected years between 1960 and 2003. Use the graph to estimate to the nearest percent women's earnings as a percentage of men's in 2003. Okay, so we're going to take a look at the graph itself. We're going to estimate 2003, which is approximately right here, and we're going to go up to the graph. There's a point right here, and it's above 75. It's not to 80, so I would guess it's approximately, estimating here, 76, but remember this is a percent. So in 2003, women earn approximately 76% of what men earn for the exact same job with the exact same experience. The function f of x is equal to 0.012x squared minus 0.16x plus 60 models the median women's earnings as a percentage of men's. X years after 1960, make sure you pay attention to what X represents. That's the number of years since 1960. Use the function, that means you're going to be plugging numbers into the function, to find women's earnings as a percentage in 2003. Round to the nearest tenth of a percent. So first thing you have to do is figure out what X value you're going to plug in. Remember, X is the number of years since 1960, and we're trying to figure out in 2003. So how many years is it between 1960 and 2003? Well, it's 43 years. So our X is going to be 43 there. And we're going to take 43 and we're going to plug it in for X. In every time you see an X value, you're going to plug in 43. So, where is it? Right here. So you're going to take 43 and you're going to plug it in here, and you're going to plug it in there. So f of 43, not 44, 43 is equal to, remember when you plug numbers in, you got to plug them in parentheses, minus times 43 plus 60. This is a calculator question. I'm not going to do this in my head, and since the file actually has it already calculated, I'm just going to go ahead and skip to the next page. But you would square first, then multiply, then add or subtract. So when you do that, you get approximately, the calculator will give you something like this, but remember it says round to the nearest tenth of a percent. Nearest tenth is one place value, so the answer would be 75.3, or approximately 75.3%, and we were pretty close when we said 46 according to the graph, or 76, I'm sorry. All right, I'm going to stop here for now, do part 2 in a different video.